The National Estuary and Research Reserve System has a system-wide monitoring program. The acronym for that is SWAMP. The real strength of the SWAMP program is that we use exactly the same instruments and the same protocols at all 29 reserves. And so the backbone of this SWAMP program, as we call it, is water quality measurements and meteorological measurements. So we have, at the Mission-Aransas Reserve, we have 5 permanent stations that measure these water quality parameters, and we have 1 meteorological station. So at each of these stations, we're measuring a number of different water quality parameters: water temperature, salinity, oxygen, pH, chlorophyll, and turbidity. And we're doing that at 15-minute intervals. We do that 24 hours a day, 365 days a year.
Taking these sondes out twice a month, and we're swapping them. So just to go through a typical day for me, it starts a day ahead. So I'll be pre-calling or calibrating sondes to make sure they're at their peak performance before I put them out into the bay to monitor the water quality. So we have the highest quality data, and I know all the probes are working, the sonde is working, everything looks good. We'll start pretty early because it's a pretty long day, because we have about 5 stations we're going to hit all throughout Mission-Aransas Estuary. And I'll take each station. We'll start at Aransas Bay, and I'll take a sonde and I'll swap it with the sonde that's already out there. So then that way we'll get a new fresh sonde out there that's going to be working really well, and I'll take that old sonde, and at the end of the day we'll take it back to the lab, and then I'll post-cal the next day. But we're going to hit up all those sondes at all 5 stations, and we'll be taking water quality samples with the Van Doorn, which is this kind of cylindrical tube that will send down at the same level, about a half a meter off the bottom as the sonde. So we're getting that same kind of water. And we're going to take water samples from that. It's the meteorological station. And I'll make sure all the sensors are working right. I'll download all that data, all the weather data, just to have a backup. Also, while we're in the field, we always pull a 2-minute plankton tow. Right before we get to the station, it's going to be adjacent to the station, and we pull it, we hold it alongside the boat, it's in the water, and we'll pull that for 2 minutes at a constant speed, and then we'll pull that plankton tow up, and we'll collect those samples, about 2 per station, and we'll filter them for zooplankton.
Once they get the samples back, I filter the nutrients through a 0.4 micron filter and into some tubes, and then we put those in the freezer for the next day whenever they analyze them. Then I move on to the flow cam, where we process the samples, taking images of all of the organisms that are in like a 1 ml sample. And once those samples have been run, then I move along to the TSS, where we filter upwards of 500 mils of the sample just to try to get a 1 milligram sample for analysis.
I also do vegetation monitoring on an annual basis. So compared to the water quality, which is done on a very high temporal scale, so we do it every 15 minutes we are measuring it. Vegetation doesn't change as fast, and it also involves a little bit more effort, so we go out once a year with the help of the stewardship sector and measure both marsh areas, we measure mangrove areas, and submerged aquatic vegetation. And so again, we want to look at how this changes over the longer period of time. We have now over almost 15 years of data from the reserve, so we can start to look at things like how the changing climate is affecting the functioning of our reserve, and also to provide information for resource managers. So for example, how is the productivity of the reserve changing? How is that going to affect fish populations? How is it going to affect other ecosystem services that the estuary provides?